Now, Lagrange's quadratic interpolation. Lagrange's quadratic interpolation. Previously, we have seen Lagrange's linear interpolation, straight line, now quadratic interpolation. So, consider the polynomial. Consider the polynomial P2x. P2 stands for quadratic. What is the quadratic expression in general? A1 naught plus A1x plus A2x square. Quadratic expression where we have to find the arbitrary constants A0, A1 and A2. And A2 are arbitrary constants. Okay. And how to determine these constants? By using interpolatory conditions, right? So which satisfies, this polynomial satisfies the interpolatory conditions. You know what is meant by interpolatory conditions? Means p of x equal to f of x at each point, which satisfies the interpolatory conditions. What are the interpolatory conditions? First one, p2 of x naught equal to f of x naught. Okay. Next, p2 of x1 equal to f of x1. And one more is what? P2 of x2 is equal to f of x2. Why we are considering three conditions? Because three unknown constants are there, a0, a1, a2. So we are considering three interpolatory conditions. Okay. Therefore, substitute. Now at x equal to x0, what is the value? Take this as 1. At x equal to x0, 1 implies, what is this one? P2 of x0 equal to, what is the value? A0 plus A1 x0 plus A2 x0 square. And what is this is equal to? F of x0. At x equal to x1, equation 1 becomes P2 of x1 is equal to A0 A1 x1 plus A2 x1 square equal to, what is this? P2 of x1 value? F of x1. And the third one, what is that? At x equal to x2, equation 1 becomes P2 of x2 is equal to A0 plus A1 x2 plus A2 x2 square equal to f of x2. Now consider this system of equation. Okay. And in this system, what are the unknowns? A0, A1, A2. I have to eliminate these arbitrary constants. So for that, what is the condition? Eliminating A0, A1, A2, we obtain the required quadratic polynomial, as, what is this one? Von Neumann's determinant. You know that. What is that? The first polynomial equation P2 A0. What is A0 quotient? Right, A0 quotient is 1, A1 quotient is x, and A2 quotient is x square. Now after substitution at x equal to x0 function, next A0 quotient, A1 quotient, A2 quotient. Similarly another one, f of x1 1, x1 square. Another one, f of x2 1, x2 square. This von Neumann determinant must be equal to 0. You know this interpolation exists when von Neumann determinant is equal to 0. Expanding this determinant, we get what is the AC? P2x into d naught minus f of x naught. Expansion by using first column, f of x naught into d1 plus f of x1 into d2 minus f of x2 into d3 equal to 0. Okay, first p2x into What is this? When I consider p2x, delete the first column and first row, then determinant of this one, right? Determinant of this matrix. So where, now let me write what is d naught. Clearly p2x, what is the cofactor of p2x? This one, 1 1 1, x naught square, x1 square, x2 square. This is the determinant. And if I expand this determinant, what I am getting, x0 minus x1, x1 minus x2, x2 minus x0, x2 minus x0. And remember how to write this. First x0, next x1, next x2, next again x0. So first x0 minus x1, next after x0 what is the value? X1. After x1 what is the value? X2. Next after x1 what is the value? X2. X2 then x0, like this. Okay. And d1 is, d1 is 1 x square, 1 x1 square, 1 x2 square. Same logic here also. Now in place of 1 x0 x square, x is there, so x minus x1, x1 minus x2, and x2 minus x. And what are the terms here? Cyclic form: x, x1, x2, x2 x1, x1 to x2, x2 to again x. And d2 is 1 x square, 1 x0 square, 1 x2 square. Same logic here also. After expanding and simplifying, I am getting this x0 minus x2 and x2 minus x, x2 minus x. And what is here the terminology? X, next x0, next x2, next x. Okay, x minus x0 after x, x0, x0 after x0, x2, like this. Similarly, what is another? d3 is there. What is d3 here? d3 is 1 x square, 1 x0 square, 1 x1 square. Okay, so what is this expansion? X minus x0, x0 minus x1, x1 minus x. And how to write how to remember this? First x, then x0, next x1, next x, right? According to that you write the differences in cyclic form, right? Therefore what is p2x? Finally p2x is equal to, okay, let us express this p2x into d naught minus f of x into d1 plus f of x1 into d2 minus f of x2 into d3 equal to 0. What this gives? This gives p2x is equal to how much? d1 by, take all the terms that side and divided by d naught, d1 by d naught f of x naught minus d2 by d naught f of x1 plus d3 by d naught f of x3, x2, f of x2, right? Okay, then after simplification, d1 by d naught, we know what is d1, what is d2, and what is d3. So after simplification, what I am getting? p2 of x equal to what? X minus x1 into x minus x2 by, in the numerator replace this x by x naught, x naught minus x1, x naught minus x2 multiplied by f of x naught plus second term. In the second term, delete the difference x minus x1 and write the remaining differences, product of the differences, x minus x naught, x minus x2, and delete the difference x minus x1. And in denominator replace x by x1, x1 minus x2, f of x1. And in the third term you delete the difference x minus x2, write the remaining two differences, product, and replace x by x2 minus x0, x2 minus x1 multiplied by f of x2, multiplied by f of x2. And entire this can be written in a simplified form: l0 x into f of x0 plus l1 x into f of x1 plus l2 x into f of x2, f of x2. This is the form. And what is L naught? What is this L naught? L naught is this bracket. And what is L1? This bracket. And what is L2? This bracket. Okay, is quadratic Lagrange interpolating polynomial. Lagrange interpolating polynomial. Okay, either you remember this or you remember this, where, see how to remember. L naught means delete the difference x minus x naught and write the remaining two differences and replace x by x naught in denominator. This is L naught. Coming to L1, delete the difference x minus x1 and write the remaining two differences and replace x by x1 in denominator, x1 minus x2. Similarly, third one, L2 of x means delete the difference x minus x2 and write the remaining differences by replace x by x2. This is x2 minus x1. These are our Lagrange's fundamental polynomials, right? Lagrange's fundamental polynomials. Okay, and what is the error term? You know, now the truncation error in quadratic interpolation is, let us denote that e2 of fx is equal to, one can write directly. Okay, same derivation as in linear interpolation. What is e2 of f of x is what? What is this? Exact minus approximate curve, right? And so this value is e2 of f of x is equal to 1 by 3 factorial x minus x naught, x minus x1, x minus x2 into f triple derivative xi, where xi belongs to, as usual, x naught to x2 value. Xi belongs to x naught to x2 value. And what is the bound? The bound on truncation error. The bound on truncation error is mod e2 of f of x, fx is less than or equal to 1 by 3 factorial mod x minus x naught, x minus x1, x minus x2. Okay, x minus x2 mod and m3. Okay, remember this is important formula, where what is m3? Where m3 is maximum of triple derivative of f. And what is x lies between, what is the interval we have taken? 3 points, x naught to x3. This is error bound. Remember this point. Now finally, Lagrange's higher order interpolation. One can say higher order interpolation. What is the meaning of this? It's a final Lagrange's interpolation for n distinct points. Nothing but one can write Lagrange's interpolation formula, not linear, not quadratic, general formula. Lagrange's interpolation formula. What is that? The Lagrange's interpolation, interpolation polynomial of degree n, generalization of degree n, based on n plus 1 distinct points. What are those points? A equal to x naught less than x1 less than and so on, xn and the last point is x naught to xn, n plus 1 points are here, and the Lagrange's interpolation polynomial of degree n based on distinct points is what is that? P of x. One can write P n x, okay? On generalization, I am taking P of x equal to summation I equal to 0 to n Lagrange's fundamental polynomials Lix multiplied by f of xi multiplied by f of xi. Okay, nothing but one can write this is what? L naught x into f of x naught plus L1 x into f of x1 up to here linear. And if I write one more, L2x into f of x2, this is quadratic. So generalization, lastly lnx into f of xn, lnx into f of xn. Okay, this is where what are lix? Where lix are Lagrange fundamental polynomials. Lagrange fundamental polynomial given by, you know how to define this. Okay, generalization Lix equal to what? Delete the difference x minus xi and write all the differences x minus x naught, x minus x1, okay, x minus x2, dash what is this one? X minus xi minus 1 before term of ith term. Now x minus xi deleted, so what is the next point? X minus xi plus 1, x minus xi plus 1 and x minus xi plus 2, and lastly x minus xn whole divided by now replace x by xi, that's it, xi minus x naught, xi minus x1, xi minus x2, okay, and here xi minus xi minus 1, xi minus xi plus 1, and so on, xi minus xn. This is Lagrange's fundamental polynomial. So higher degree Lagrange's interpolation formula is this, you have to remember. Okay, so if the length of the data is given, remember, if the length of the data is n plus 1, then we will get a polynomial of degree n, only. Okay, that's it. We are, and remember one more point, using interpolation we can find only the polynomials. Not any other function, not exponential, not trigonometric, like that. We can find only polynomials by using interpolation. Now the truncation error in Lagrange's interpolation polynomial is, what is the truncation error? En of fx, equal to f of x minus p of x, and what is that? 1 by n factorial x minus x naught, x minus x1, okay, and so on, x minus xn multiplied by, what is the derivative? N plus 1th derivative of xi, and the bound on truncation error is modulus of en of fx is less than or equal to 1 by n factorial. What is that? Maximum of x minus x naught, x minus x1, and so on, x minus xn mod close mn, where what is mn? You know, mn is what? Maximum of modulus of n plus 1th derivative, where x belongs to where? X less than or equal to xn. That's it. Generalization. This is error bound. Okay. With this, Lagrange's interpolation derivation is finished.